here, we'll start with number 5, asks what the order of the reaction is with respect to ClO2. Now, to find the order of the reaction here, we want to look at these two numbers, experiment 1 and 2, and the initial rates in molar per second, because these are where there's a change in molarity for ClO2. So we first want to find the value of the change here. So what we want to do is divide the second experiment molarity by the first. So we're going to have 0.020 divided by 0.060, and that will give us 1/3. These are molar. And then for the initial rate, we're going to take 0.00276 divided by 0.0248. And this is going to give us, if I get my calculator real quick, it's going to give us 0.00276 divided by 0.0248. 0.111. And so what we want to do is we want to find 1/3 to the blank power, or x power, equals 0.111. If you think about the fact that this is 0.333, you can take this, and squaring it will give you 0.0111. And so our x value here is 2. So the order of the reaction for A, and ClO2, we can represent this as the change concentration of A, and we can say this is the concentration of B for the rest of these problems. Then this will be have a order of 2. So we're going to have the concentration of ClO2, and the order is 2. Now, similarly, for question 6, it's asking about the OH minus order in this reaction. Now here we're going to look at 2 and 3, because these are the ones that have a change in molarity of OH minus. So similarly, we're going to do 0.090 divided by 0.030, and that's going to equal 3. And we can do the same over here. And so it's going to be 3 to the x equals 0.00828 divided by 0.00276. And if I get the calculator again, 0.00828 divided by 0.00276, and that is exactly 3. So 3 to the blank equals 3, 3 to the first is 3, and our answer here is going to be B. And I should probably circle this one as well. So let me write up here. I'm going to have to erase this in a minute. Our reaction equation is going to be R equals our constant, which is the rate constant here that we're going to solve for in question 7, times the concentration of ClO2 to the second for the second order times OH minus concentration to the first for the first order. Now let me go ahead and, whoops, that's the wrong tool. Let me erase this part down here. My eraser tool will cooperate. I think I made it a little too big. There we go. Okay, and let me get my other tool back here. Okay, so we have this equation here. So what we can do is essentially plug in one of these rows, these three values here, into this, and it doesn't really matter which one we choose, and we will get our K, our rate constant. So our rate, which is going to be in molar per second, equals our constant, which we don't have the units for yet, times, and as a note, these are all molar per second, and the molar per second goes inside of the brackets. So for this one, I'm sorry, not molar per, just molar. This one is molar squared, and this one is molar, because there's a first here, just molar to the first. And so let me plug in, I'll just use the first row here, 0.060 molar squared times 0.030 molar to the first equals our R over here, which is 0.0248 molar per second. So if we take the molars out, we can ignore those for now. So this will have units, as I said, of molar squared and molar to the first. And we'll look at the units in a minute. But first we want to take 0.060 squared, which equals, let me get my calculator again, 0.060 squared, 0.0036, 0.0036 times 0.030 and times this value, because that was just 0.030 to the first, times 0.0036 is 0.000108. And this was 0.030. Now, when we multiply these two together, these are going to combine to have units of molar to the third, and so molar to the third equals 0.0248 molar per second. And one of these molars will cancel, so we'll have molar squared over here. And if we divide this by 0.000108, let me do that. 0.0248 divided by 0.000108 will give us 229.629. Let me change colors for our answer. 229.6. And there's only going to be 3 significant digits actually here, so that's going to round to 230. And units, we will have, because this is dividing here by molar squared, second stays on the bottom, and since we canceled one molar unit, it's going to have units on the bottom of molar squared seconds. So 230 times second to the -1 molar to the -2. And it doesn't actually ask what the units are, so that wasn't as important. But that's good to know how to calculate those. And our answer here will be E 230.